In this section, we'll be talking about power. We learned about power in AP Physics 1 or AP Physics C or General Physics. We learned that power is the rate at which work is done. So power is work over time or change in potential energy over time. Remember that energy and work can be equivalent. Just a couple of reminders that work is force times distance at its most basic, and force times distance is newtons times meters, and our unit for that is the joule. And then power has a unit of joules per second because we're taking energy or work per unit time. And the unit for power, when we combine joules over seconds, we call it the watt. So power is measured in watts. Or you can just write a capital W. Okay, so back to power. So we also know that change in voltage or potential difference is equal to change in potential energy over charge. And we can rearrange that to say potential energy equals charge times potential difference. And if I rearrange this, I get power equals Q. Let me zoom in here. Power equals Q, that's charge, times voltage over time. But we know that charge over time is current. So I've replaced charge over time with current, and then we still have times voltage. So now we have a formula for power. We can say that power equals voltage times current. We can combine this formula, this new formula for power, with V equals IR, and I can do it in two different ways. If I take P equals VI and V equals IR, I can make a simple substitution. I can plug in IR for V, and if I do that, I get that P equals IR times I, or P equals I squared R. That's one useful formula. Another thing I can do is rearrange Ohm's law to solve it for current. And when I do that, I'll be plugging in V over R for I. So P equals IR. Instead of, I messed that up. Here we go. P equals VI. And instead of writing I, I'm going to write V over R. So I get power equals V squared over R. So those are just two useful equations for solving problems. So here's an example. Find the current flowing through a 100-watt light bulb with household voltage, and then find the resistance of the light bulb. So the power is 100 watts, and the voltage is 120 volts, and I want to find the current. So I'd use P equals IV. So 100 equals I times 120. And when I divide, I'm going to get 5/6, I think. I'm going to get that the current is 0.83 amps. I can also find the resistance if I used P equals V squared over R, where P is 100 and V is 120. So I would solve that using algebra. I can use the means extremes property to say that R is equal to 120 squared over 100. So I get 144. So on those household light bulbs, you can figure out what the resistance is by looking at the power. All right, that concludes this section on power, and next time we'll be talking about complex circuits.